Okay, so we've seen the z-score formula. Now we're going to see a z-score formula that's slightly modified. Okay, because a mean itself is its own random variable. Like x was the variable we were trying to test. Now we're going to test the sample mean. We'll subtract it by some population mean. So these are slightly different, right? This is a sample mean, this is a population mean. Then divide it by the standard deviation over the square root of n. Okay, or that could be capital sigma like we saw before. Maybe this will make it look more familiar. The square root of n part is new. That stands for the sample size, the number of people in our study. Let's see here. So past research, we got a population mean. That's like the m. It's 65. Standard deviation is 20. Biologist is taking a sample of 15 wolves. That means n equals 15. I think all we have to do, since they got this cool little calculator, is we just have to drag things to where they're supposed to be. Standard deviation is 20, so I'm going to drag this to... standard deviation of the mean, okay. So this right here is the standard deviation of the mean, okay? That's what they mean when they say this. The standard deviation of the mean. And so that's just this little formula here. It's the standard deviation of the mean is the standard deviation of the data set divided by the square root of the sample size. So the standard deviation of the data set was 20, and the sample size was 15. So if we do this, the square root of 15 is 3.872, blah, blah, blah. And if we take 20 and divide by the square root, you get 5.16398. I'll round off there. 5.16398. That's our standard deviation of the mean. 5.16. Oh my gosh. 5.16. That rounds up. 5.16 rounds up to 5.2. Okay. Let's see what else we have to do. The mean of 65. Move that over to 65. I think that's all they want us to do for this question. Yeah, okay. So the big idea here is that we used to deal with just one number, with x. But if you want to calculate a probability that you get a sample mean that's a certain number, then the sample mean has a slightly different standard deviation. Same type of thing for this question here. We're asked for sigma x bar. So that means we want to calculate the standard deviation of the mean. Sigma x bar is the standard deviation of the mean. It's got to follow this formula. There's 150 businesses, so that's our n. Our standard deviation, that's a bad 0. That's a better 0. That's a little bit of a better 0. That's still not a good 0. Standard deviation is 25. So if we do the square root of 150 in our calculator, it's like 12.24745. So if we divide those two, we get 2.0 if I round to the first decimal place. So our standard deviation of the mean is 2.0. So there's 2. And then it has a mean of 81. I think that's everything for this part, but there's a second part to this question, unlike the last one. Was the probability that the sample mean for sample size of 150 will be more than 82? They give you a table. If you don't have a table, you could just search z-score to percentile calculator online. Then all you have to do is plug in your z-score and it can tell you what you need. Just make sure to click like one-sided if that comes up. But we got a table for this question. What is the probability that the sample mean for sample size of 150 will be more than 82? So going back to that z-score formula we saw at the beginning of this video, we need to calculate a z-score and we're asked to find the probability that the sample mean will be more than 82. So we need to plug in 82 for the sample mean, and we need to subtract it by the population mean, which was 81. They gave that to us at the top. So subtract it by 81, and then divide it by 2.0, that standard deviation of the mean that we just calculated. Sometimes called the standard error. So 82 minus 1 makes 1. 1 over 2, that's 0.5 for our z-score. And they want the probability of being greater than 0.5. So here's 0.5. This is what the area looks like to be greater than 0.5. So 0.5 in our formula. Remember, the table always gives you the probability of being less than the value. So at 0.5, we have a z-score value. The area to the left is 0.6915. So that means this area is 1 minus 0.6915. So it gives us 0.3085, which is 30.85%. Right? They asked for a percent in this one, not a probability. So I converted 30.85 to a percent by moving the decimal place twice.